Hi, I'm Michael Gorga. I'm Director of the Clinical Sensory Physiology Lab at Boys Town National Research Hospital in Omaha. And you are?
My name is Maureen Shader, and I am a PhD student at the University of Maryland, College Park. And I recently, before starting there, got my AUD at Gallaudet University in Washington, D.C.
So you're not in an AUD PhD program. You were AUD and then PhD.
Yes, separate
So,
universities.
so I'm guessing your path is not unlike mine.
Mm-hmm.
When I was your age, which is almost hard to remember, I had a master's degree in audiology and was a clinical audiologist and decided I needed additional training in order to learn more about how the auditory system worked in its normal state and its impaired state. And that motivated me to go on for a PhD.
Yeah, I found something similar where I was working clinically with cochlear implant recipients and was really confused as to why some people did really well and other people didn't do well, in the lack of really knowing why. And that's one of the reasons why I went back to school, to really look at trying to find some reasons why that is.
For me, one of the really important parts of my training, which I've carried now for 40 years, is we need to understand fundamental processes in the auditory system. If those things do not change, evolution doesn't happen that quickly. So if we can understand fundamental processes, then as our careers develop, we apply that knowledge to what it is we're seeing in ears with hearing loss. And much of what I talked about last night, much of that work was motivated by a knowledge from my colleagues who do basic science and animal models. How can I take that information and learn something about how humans with hearing loss, what their systems are doing to the sound they're receiving? And so I think it's very important to build that basic understanding of underlying physiology and behavior. I think a basic understanding of psychoacoustics is really important too. And then as we move into our careers as clinical and translational researchers, we can use that knowledge to gain much better insights into what's happening when hearing loss exists.
So it sounds like you have this really nice balance of basic science and clinical research or application, and that's something that I dream about in a career and would love that, but I find that those are hard to come by. Do you have any advice for finding those kinds of jobs?
I think those jobs exist in many speech and hearing programs.
Okay.
But I never did fundamental auditory physiology. I do not, it's passé now, but I never did single unit recordings in the auditory nerve of lower animals. But I understood that work. I read that literature. It's in my background. And so my advice is, you don't need to be able to use and perform all these highly skilled experimental techniques that people are using in animal models, but we do need to understand the questions those people were asking so that we can then see in the human model how we can learn about it where we can't use those invasive techniques. We're constrained not to do things to humans that my colleagues in physiology do to animals. So I would say, do not focus simply on clinical coursework.
Okay.
Get that basic science background. Even though you're not going to necessarily do those sorts of things in the future, you will fall back on that and rely upon it to help guide you in the interpretation of the results you see, which I think is very important. There was no time in the talk yesterday to go into some of the details of things. There was mostly clinical and translational decisions there. But even something as simple as picking the way to turn sine waves on and off, we use a Blackman window. There are other windowing functions that get much greater side lobe energy reduction at the expense of widening the main energy lobe. We settled on the Blackman. And the reason we did is based upon auditory physiology. in a single auditory nerve fiber, which is a fundamental measure of the frequency resolution of the normal cochlea, there is about a 60 dB difference between threshold at the best frequency in that tuning curve, its characteristic frequency, and the low frequency tail of that tuning curve. So 60 dB is all the frequency resolution you get in the normal case. Once you make the sound bigger than that, or you create a greater difference between the side lobe and the main energy lobe, it's wasted. So all you're doing is widening the main energy lobe with no benefit in terms of what limits are imposed upon you by the normal auditory system. So we selected a Blackman window based on what we knew about the frequency resolving capabilities of the normal cochlea.
And so you wouldn't have done that if you didn't.
If I didn't have that coursework, if I didn't know that there was the 60 dB difference. Some of the calibration stuff, I talked about why we overestimate thresholds with ABRs when hearing is normal and we underestimate when hearing loss exists. The reason why I understand why that occurs, and why I understand it is because my psychoacoustics colleagues taught me about temporal integration in ears with normal hearing. You see temporal integration in ears with normal hearing, 10, 15, 20 dB, and there's reduced or absent temporal integration in ears with hearing loss. But we're always predicting the pure tone audiogram, which is a stimulus that allows the normal ear to fully exploit temporal integration. Impaired ear could care less. Make it long, make it short, thresholds don't change very much. So as a consequence of that, you see slightly higher thresholds, predicted higher thresholds when hearing is normal, slightly lower when hearing loss exists. So we've taken that knowledge and now collected these data and applied a model to those data that are enabling us to, it's not a big effect, but it's enough to improve the agreement between ABR and behavioral threshold that has real clinical significance. So again, it's looking at basic studies, understanding what they tell us about how we behave auditorily, and then exploiting that in the clinic.
And do you think that just reading these literature from these different kind of basic science and psychoacoustics, is that enough? Or
Okay.
do you think
Here's what I would tell to old people, to young people.
Okay.
Go find old people who've done this stuff before and talk with them, because there is a wealth of knowledge in not necessarily in my head, but in the heads of many of my colleagues. It is hard to just read and understand things.
Yeah.
Now, if you could read things and then discuss these things with more senior individuals who understand the literature better, I think that would be useful.